Hello again, and welcome back to Java for Chem Eng. Last time we talked about how to get started programming in Java, and we briefly touched on variable declaration and data types. Today, we are going to continue this discussion. If you'll recall from last time, a variable is an object we can use to store and access data. A variable is created through what is known as a variable declaration. A variable declaration, the basic syntax looks like this. You declare the data type, you then give the variable a name, you then use the equal sign as the assignment operator, you give it a value, and then you finish that off with a semicolon. And we can think of this as being made up of two main parts, the variable creation and the value assignment. So for a concrete example, let's create a string, and we'll call it myString. We will then give this the value of hello. Remember from last time that whenever you declare a string variable, the value has to be encapsulated within two quotation marks. So we can think of this part as being the variable creation, and of this part as being the value assignment. The one thing I did not mention from last time is that we can actually split up these two parts onto two separate lines. So what we can do is we can say string myString, semicolon, and then we can call myString later and give it the value of hello. This is a very important tool, but it's always important to note that if you're going to use a variable, that you always give it a value before you use it. So for example, if we were to print this variable, we'll print myString, but say we forgot to give it a value, the computer's going to get mad at us and it's going to give us an error. This is because whenever we pass a variable to the computer, it's expecting that variable to point to some value. And if it doesn't point to a value, the computer gets confused. So strings are nice and all. However, whenever we're doing programming, we are typically trying to solve some sort of math problem. And so we need data types that are able to store numbers. Our two main workhorses for this are the int and the float. The int stores integer numbers, also known as whole numbers. And the float stores decimal numbers. So what we can do is we can declare an int, we'll call it myInt, and we'll give it a value of 5. And for the float, create a float, call it myFloat, and give it a value of 5.5. The important thing to note is that whenever you are declaring a float, is that if you give it a decimal value, you have to finish that off with an F. Otherwise, you'll get an error. So what we can do now is we can print the sum of these two variables. And the result will be printed to our terminal. The one thing to note about these two variable types, these two data types, is that they have a size. Both of them are only about 4 bytes. This is typically only as much as you will ever need. However, what this means is that these two data types have a minimum and maximum value they can hold. For the int, this is -2 to the power of 31, all the way up to 2 to the power of 31 minus 1. That is a very big number. That is a very big range for a number. However, it's still possible to go over that. And what that happens, you get a sort of rollover, where if you exceed the maximum number, you actually start all the way back at the bottom. So to avoid this, we have two other data types, the long and the double. The long is nothing more than an int that is 2 times the size. And the double is the same, but for the float. Two other data types you should be aware of are the char and the boolean. The char is a data type that only holds a singular character or symbol. So if we are to declare a char, we'll declare a char, call it myChar, and we'll give it a value of g. The important thing to note is that similar to a string, The value of the char needs to be encapsulated. In this case, it's within apostrophes or a single quotation mark instead of quotation marks itself. And as previously stated, it can only hold one symbol. If we give it more than that, it's going to give us an error. The Boolean is also very simple. The Boolean is just a data type that holds true or false values. So what we can do is we can declare a Boolean. We'll call it myBool, and we'll give it the value of true. So far, all the data types we have looked at are known as primitive data types. The other kind of data types we need to look at are reference data types. So, what's the difference between these two? Well, simply put, a primitive data type is a data type that does not reference other primitive data types. And a reference data type is all data types that are not primitive data types. So that may not be helpful, so what does this mean in practice? Well, here we'll draw a memory diagram. A memory diagram is nothing more than a visual representation of how data is stored in the computer. So here we have our primitive object, and all it does is it points to some place in the memory, and that memory holds a value. A reference data type is similar. Here we have our memory diagram, and here we have our reference object, and this points to some place in the memory, but it doesn't point towards a value. It points towards a memory address, and this points to somewhere else that holds a value. So why might we do something like this? I think this can be illustrated pretty well with the array. The array is nothing more than a collection of other data types. So we can have an int array, and all this is a collection of integer data types. So here we can store a 5, a 29, a 4, and a 0. But more accurately what this is it's an object that points to a collection of references. So here we don't have a 5, a 29, a 4, or a 0. What we have is something that points towards a 5, a 29, a 4, and a 0. I hope this has been illustrative. So to return back to our code, let's create an array. The basic syntax for an array looks something like this. We declare the data type we want to create a collection of. We then follow that up with a pair of square brackets. We give our array a name. We then use the equal sign, and then the values we want to enclose, we surround them with a pair of curly brackets. We then declare our values, and we separate our values using commas. We then finish that off with a semicolon. For a concrete example, let's create an integer array. So we will declare the int data type, square brackets, give that a name like my int array, assignment operator, and then curly brackets. And within those curly brackets, we can now give it values like 5, 29, 4, and 0, and finish that off with a semicolon. Let's do the same thing, but let's create an array of char data types. So we'll declare the char data type, follow that up with a pair of square brackets, give it a name like my message, assignment operator, and then curly brackets. Within the curly brackets, we'll give it a capital H, an I, and an exclamation mark. Now you'll notice that this is fairly similar to just declaring a string, giving it a name, and then giving it the value of hi. And you would be correct. That's because these two things are actually the exact same thing. A string is nothing more than an array of char data types. A string is a reference type. I think this is a good place to end this episode. This one was a bit theory intense, and so will the next episode on operators. However, after that, we will be getting back to more of the hands-on coding stuff, where you will begin to apply a lot of what you have learned here. Thank you for watching, and I'll see you in the next episode.